This example deals with more complicated logarithmic equations. Here's the first one, log base 4 of x minus 3 equals negative log base 4 of x minus 6 plus 1. Now this time we have a log on the left and a log on the right. We actually need to put them both on one side of the equal sign. So log base 4, x minus 3. I'm just going to add log base 4 of x minus 6 to both sides equals 1. Now, the two logs that we have on the left-hand side, we are going to combine it into one log. So this is log base 4 of x minus 3 times x minus 6 equals 1. Now we can go ahead and turn this into an exponential equation. So this is 4 to the first power equals x minus 3, x minus 6. Now, 4 to the first power is just 4. X minus 3 times x minus 6, this is x squared, minus 6x minus 3x plus 18. We'll go ahead and put everything on one side, set it equal to 0, then do like terms x squared minus 6x minus 3x plus 18 minus 4 equals 0. So x squared minus 9x plus 14 equals 0. So now we have a quadratic equation that we can solve. So let's go ahead and do that. This is factorable. Two numbers that multiply to 14 and add to negative 9. That would be 7 and 2. Both of these are negative. Negative 2 plus negative 7 is negative 9. Negative 2 times negative 7 is 14. Now we can use the zero factor property. X minus 2 equals 0, or x minus 7 equals 0. So that means x equals 2 or x equals 7. Now, for these specific equations, you actually have to check your answers. So let's go ahead and do that. We're going to start with checking x equals 2. So that means plug it back into the original equation and see if the left-hand side equals the right-hand side. Log base 4 of 2 minus 3, does that equal to negative log base 4 of 2 minus 6 plus 1? Now, look what happens here. Log base 4 of negative 1. That actually cannot happen. This number right here is negative. That is outside of the domain for the logarithmic function. So actually x equals 2 is not a solution. You cannot have a negative inside of a logarithmic function. So what I'm going to do is I'm going to go ahead and cross out x equals 2. That's not part of our answer. Let's go ahead and check the other one. X equals 7. So this is log base 4 of 7 minus 3. Does that equal to negative log base 4 of 7 minus 6 plus 1? This is log base 4 of 4. Does that equal to negative log base 4 of 1 plus 1? Log base 4 of 4 is 1. And negative log base 4 of 1 is 0 plus 1. So 1 equals 1. So yes, 7 is the solution to this equation. Just 7, not x equals 2. X equals 2 did not check out. You do have to check every single one of these. Let's try it again. Negative log base 2 of x minus 4 equals 3 minus log base 2 of x plus 3. Okay, we need to put both logs on one side. So negative log base 2 of x minus 4 plus log base 2 of x plus 3 equals 3. Now, you can go ahead and combine them here, but I'm going to rewrite it one more time. The positive log first, and then the negative log, just to make our lives a little bit easier on the next step. Okay, now I'm going to combine these two logs. They're attached by a minus sign. That means the expressions inside will be divided. Log base 2 of x plus 3 divided by x minus 4 equals 3. Now we can turn it into an exponential function. 2 to the third power equals x plus 3 divided by x minus 4. 2 to the third is 8. X plus 3 divided by x minus 4. Now to get rid of the denominator, we have to multiply both sides of the equation by the denominator. So that's x minus 4 times 8 equals x plus 3. Distribute the 8 on the left-hand side. 8x minus 32 equals x plus 3. Put all the x's on one side and all the numbers on the other side. Go ahead and go over here. So 8x minus x equals 3 plus 32. 8x minus x is 7x. And 3 plus 32 is 35. So x equals 35 divided by 7, which is 5. We do have to check this, but just in case you don't have time for the actual check where you're plugging everything in and seeing if the left equals the right, there is a quick check option. In quick check, we are just plugging in the x value inside of the logs and making sure that the inside of the logarithmic function is greater than 0. So log base 2 instead of the x, I'm going to plug in 5 minus 4. That's the same as log base 2 of 1. Since 1 is bigger than 0, we are okay. And then we have another log base 2 of 5 plus 3. Well, that's log base 2 of 8, and 8 is also bigger than 0. So we are okay on this one too. So we'll go ahead and box in this answer. This is the actual answer to this question. Okay, let's try it one more time. Sometimes log base 2 of x minus 9 equals 2 plus log base 2x minus 6. Sometimes you look at the problem and it looks fine. But let's go ahead and solve it. So once again, all the logs need to be on one side. So log base 2 of x minus 9 minus log base 2 of x minus 6 equals 2. Combining the two logs that are on the left, this is log base 2 of x minus 9 divided by x minus 6 equals 2. Turn it into the exponential. 2 squared equals x minus 9 divided by x minus 6. 4 is x minus 9 divided by x minus 6. Just like in the previous example, we have to multiply by the denominator. So 4 times x minus 6 equals x minus 9. 4x minus 24 equals x minus 9. Put all the x's on one side and all the numbers on the other side. 4x minus x equals negative 9 plus 24. 3x equals positive 15, which means x equals 15 over 3. or 5 again. Now don't forget to check. I am going to do the quick check. So in the first one, log base 2 of 5 minus 9. Log base 2 of negative 4. This time, the number inside the logarithmic expression is negative. So negative 4 is less than 0. That's not possible, which means that x equals 5 is actually an extraneous solution. It's not part of the solutions for this equation. So that means that's the only number we got when we solved it. So that means that this particular equation has no solutions. Okay, one more example on a different type of logarithmic equations. Natural log of 7 equals natural log of x plus 2 plus natural log of 2. Now I have 3 different logs. 2 of them are on the right-hand side. I'm going to go ahead and combine these 2 into 1. So this is natural log of 7 equals natural log of x plus 2 times 2. Now, we have a natural log on one side and a natural log on the other side. Nothing else is attached to the logs. They're not multiplied by any numbers. They're not adding any numbers to them, not subtracting anything from them. So in this case, just in this case, when there's a log on one side and a log on the other side, you can drop the logs and just end up with 7 equals x plus 2 times 2. Now we can just solve this linear equation. 7 equals 2x plus 4. Subtract 4 from both sides. 3 equals 2x, and x equals 3/2. You should check this one too. If your log does not have an x, you don't have to check it since it's not going to change. So we just need to check this one, ln of 3/2 plus 2. Now that's the same as ln of, that's 2 plus 1.5, so it's 3.5. This number is bigger than 0, it's positive, so it's okay. Which means x equals 3/2.